Hello, my name is Greg and I'm with Technical Marketing and MathWorks. The purpose of this webinar is to show how to use Simulink to develop algorithms for Raspberry Pi 3 and Android devices and increase awareness on the capabilities available in Simulink hardware support packages. In particular, I show how to create new models that establish communication between Raspberry Pi 3 and supported Android devices. And I do this with three examples. In the first one, we blink the green LED of a Raspberry Pi board by tapping on a button on the touchscreen of an Android device. On the second one, we implement the surveillance camera example included in the documentation of both hardware support packages for Raspberry Pi and Android, keeping in mind that you can also find documentation on how to do this with iOS devices on the Simulink support package for iOS. Finally, on the third example, we elaborate on the second one and add a button to activate the video feed transmitted from Raspberry Pi to Android. If you're new to Simulink, we recommend the Simulink Getting Started example and the interactive Simulink tutorial to get up and running with Simulink. Also, you may want to check out the Getting Started examples included in the Raspberry Pi and Android support packages from Simulink. These materials will familiarize you with all you need to take the most advantage of this webinar. This is the complete list of hardware and software used. It includes the Raspberry Pi 3 and its accessories, the Google Nexus device and its cable, and a wireless router and its power supply. On the software side, the examples shown on this webinar require MATLAB Release 2016b, Simulink, Computer Vision System Toolbox, Image Processing Toolbox, and the Simulink hardware support packages for Raspberry Pi and Android. On this first example, I will show you how to blink the green LED of the Raspberry Pi 3 board using one button on the touchscreen of your Android device. To do this, we need a Wi-Fi network available to which all devices can connect, including your computer. The router should assign an IP address to each device, with a number similar to the IP of your router, or the IP gateway. You can verify wireless connection between your devices by pinging from MATLAB on your computer in the following way. First, you can look at your computer's IP address by entering ipconfig. This will show you the IP address assigned to your computer by the router. Then, you can ping the IP gateway, or IP of your router. Note that the IP gateway usually shares the same first three numbers with devices connected to it. Now that you have verified that your computer is connected to the router, you can ping other devices on the network. In this case, we ping the Raspberry Pi and the Android device. With this setup, we can deploy Simulink models on Raspberry Pi and Android from your computer that use the Wi-Fi network to communicate with each other. In this case, we will use UDP communication, and all we will need are the IP addresses of the devices and the UDP receiving port to define each communication channel. For each of the devices, the hardware support packages include UDP send and receive blocks that you can use to define these channels. For this example, we will start by implementing the algorithm on this block diagram for the Raspberry Pi. This algorithm will receive UDP data from the UDP receive block and will use a switch to define behaviors for the LED on the Raspberry Pi. If the signal received is a 1 or a Boolean true, then the LED will stay on and not blink. If the signal received is a 0 or a Boolean false, then the LED will blink according to the specifications of the pulse generator. To create this block diagram, we can use the Simulink models provided with the LED control from Android device example. We will modify the model to replicate the model shown in the previous slide by including the switch, constant, pulse generator, and the data type and rate transition blocks. After the model is ready, we will specify the IP address of the Raspberry Pi on the configuration parameters to deploy the algorithm on the board. Once the model is deployed, you should see the green LED on Raspberry Pi blink. This is how it would look like. We open the documentation and open the Simulink support package for Raspberry Pi hardware documentation. Go to examples and scroll to open the LED control from Android device example. Here we go down and look for the links for the Simulink models for Raspberry Pi and Android. And we open the Raspberry Pi model. And this is the Raspberry Pi model. I'm going to maximize and center the block diagram and open space to add a few other blocks. I delete this line and I'm going to add first a switch. Next, I'm going to add the constant block that we're going to use to keep the LED from blinking. And we just leave it with the number 1. We're going to change the data type to Boolean because the green LED block requires a Boolean input. And next, I'm going to include a pulse generator. In this case, I'm going to use a sample-based pulse type with a period of 20 for 2 seconds, a pulse width of 10 for 1 second, and a sample time of 0.1. Next, I'm going to add a data type converter or a data type conversion block. Here, I want to choose Boolean. I can type it right here, or I can double click on the block and use the window dialog to select the data type. Press OK. I connect these two blocks, and next I'm going to add a block for the rate transition. I uncheck the Ensure Deterministic Data Transfer, and I leave everything as it is. This block will help us make sure that all the sample times are consistent and let the model run on hardware. I connect the signals, and this is our block diagram. Next, I'm going to update the diagram to look at the data types and make sure that all data types are correct. As you see, the switch is receiving Boolean from both sides. I can save my model. And next, I'm going to see the configuration parameters and make sure that the IP address is correct for the Raspberry Pi so that I can deploy it to the Raspberry Pi. I also looked at the username and password. And finally, I deploy to hardware. This may take a few seconds, and after this is done, we will be able to see the green LED blinking on Raspberry Pi. Next, we run the Simulink model for Android on the corresponding Android device. We can again use the files included in the LED control from Android device example and open the model. In this case, we need to configure the UDP send block to use the IP address of Raspberry Pi to send the signal produced by the LED 0 control button. Make sure that the UDP port is the same as in the Raspberry Pi model. We will set the configuration parameters to deploy to Android, and finally, we'll deploy the model. When the model is running on Android, we should see an app activating on the device, with a button that you can press to change the behavior of the LED on Raspberry Pi. To do this, we open now the Android model from the example. We double-click on the UDP send block and update the IP address to send to the Raspberry Pi. We type the IP address of the Raspberry Pi, noticing that the remote IP port is 26,000. Should be the same on the Raspberry Pi. Next, we verify that we have the Android device selected as a hardware board, and on device options, we make sure that we have the right device selected. It updates, and we click OK. At this point, we can click on Deploy to Hardware to build, compile, and run this model on the Android device. This may take a few seconds or even a minute. After the model has been deployed on the model, we can see an app deploying on the hardware on the Android device with a button that we can use to change the behavior of the LED. I tapped it once and we see the LED stop blinking. Tap again and the LED starts blinking again. On this second example, we implement the surveillance camera example included in the documentation of both hardware support packages for Raspberry Pi and Android. For this example, the additional components required are related to the Raspberry Pi setup. The rest of the setup remains the same. Let's look at the new components needed on the Raspberry Pi side. On the Raspberry Pi side, we will connect a USB webcam and a servo motor as shown in this diagram. Please note that this diagram is also included in the support package documentation with the example for the surveillance camera with Android device. Similar to the first example, in this case we will reuse the models included with the surveillance camera example. We will open the Simulink model for Raspberry Pi. Set the IP addresses of the UDP blocks inside the video send subsystem. Set the Raspberry Pi IP address in the configuration parameters of the model, and deploy the model on Raspberry Pi and observe that the webcam is active. In the second example, we'll open the documentation and we'll be implementing the example for the surveillance camera with Android device. Again, I scroll down and look for the Raspberry Pi model first. This is the Raspberry Pi model. And in this case, I'm going to be double-clicking on the video send subsystem and making sure or editing the remote IP address for Android. Notice that the remote IP port in this case is going to be 25,000 with increments of 1 for each one of the channels, for the red, green, and blue. I press OK, go to the upper level, and now all I have to do is to go to the configuration parameters pane and make sure that the address, username, and password are correct to deploy to hardware. Click OK, and now deploy to hardware. This takes a few seconds. It builds and compiles. And you should see the webcam become active on your Raspberry Pi. In this case, we see these blue lights to the left and right of the camera. That means that the webcam is active. And this should be it for the Raspberry Pi model. Next, for the Android device, we will use the model shown on this block diagram. This model, although complex, is included in the surveillance camera example, and we'll modify it only slightly with the constant and sum blocks. This model receives the image on the Android from Raspberry Pi and uses the processor on the device and the touchscreen to let you control brightness level, an image inversion function, and an edge detection function. The steps to use and deploy this model on Android are the following. Open the Simulink model for Android from the surveillance camera example. Add the sum and constant blocks. Set the IP address in the UDP block to send servomotor commands to Raspberry Pi. Set or verify the configuration parameters of the model, and deploy it on the Android device. Now we'll open the Android model. As you can see, this model is more complex. And in this case, I'm going to open some space here and delete this line to add the sum. Place it here, connect these two lines, and double click to edit the list of signs. The purpose of this modification that I'm doing here is to make sure that the camera moves to the left when on the touchscreen I slide the slide button to the left, and to the right when I slide to the right. I add the constant here with the constant value of 180, and connect it to the sum. Also, I double click on the UDP send block to send these the commands from the slide button to the Raspberry Pi, and this is the Raspberry Pi IP address. Notice that the remote IP port is 26,001. Then, because I'm on Android, I only make sure that I'm working with the correct device. I let it refresh and click OK. Now that I have this, I can deploy to hardware and see the app becoming active on the Android device. This may take a few seconds or even a minute. As you see, Simulink is generating code. Generates C code from the block diagram and compiles it to deploy on hardware. It continues the building process, and when it's ready, we'll be able to see, let me show it here, we'll be able to see the app on the Android device. And if I scroll to the right, the camera rotates to the right and to the left. And here I am. Let me scroll here. And this is it. This third example uses a push button to activate the video feed sent from Raspberry Pi to the Android device. It uses the very same setup from example 2, adding the simple circuitry shown in this diagram. On the right hand side, there is a breakout of the pins of Raspberry Pi 3. For this example, we will use pin number 4 to receive a digital signal from the push button. For this example, we will reuse the models from example 2 and only modify the model for Raspberry Pi. The model for Android is exactly the same. For the Raspberry Pi model, we will add a GPIO block, an enable port inside the video send subsystem, and an LED block. After this, all we need to do is to deploy the Raspberry Pi model. I'm going to open the Raspberry Pi model and maximize the window to add a few more blocks. I'm going to move things around here to open space. I'm going to add a GPIO block, a GPIO read block, which when I double click, I can select Raspberry Pi 3 Model B, and that's going to change the pin map associated to the block, and you can see the pin map here in this diagram. You can also change the GPIO pin number from this menu, and that's it. Now I'm going to enter into the video send subsystem and add an enable port. This enable port is going to activate the subsystem itself when it receives a signal from this port here. I'm going to do it connecting it to the GPIO read block, receiving signals from the button, from pressing the button. I'm also going to add an LED block to see the green LED turn on when I press the button. Now all I have to do is to deploy to hardware by pressing this button here. This takes some time, less than for Android, because we're building for Raspberry Pi. And now let me show you how this looks on hardware. Here are the camera and the phone, And I'm moving the camera with the slider gain here and looking out the window of my office. Now notice that when I slide the control here to the left, the view doesn't change, but when I press the button, this changes. There you go. I move the camera again, and now I have it pointing at me. But on the phone, you cannot see me yet. So what I do is that I go and press a button, and there I am. Now I'm gonna wave in front of the camera, and you cannot see that on the phone because I haven't pressed a button. I move the camera again to the right, pointing at the window of my office, and it hasn't changed on the phone. It's still showing me. But if I press a button, now it shows the window and door of my office. To go beyond this third example, here is a suggested exercise. Combine example 3 from this webinar with the motion sensor example and show us the result. You can share your project on File Exchange and embed a YouTube video to promote your project in the community. To wrap up, on this webinar we looked at getting started materials to get you up and running with Simulink in general. We provided a complete list of the hardware and software you need to control your Raspberry Pi projects from an Android device, and show you how you can do it yourself through 3 examples. Additional details about the first 2 examples are available in the Simulink support packages for Raspberry Pi and Android. The files used on this webinar are available on File Exchange for you to download, reuse, and create new projects inspired by this webinar. We look forward to seeing all the great projects you can do with Simulink and the hardware support packages.